Page 283. Okay, so we had those few problems we worked through yesterday. This is the last one we're going to work through, and we're going to use this table at the top to help us with this problem. So we see the table that gives us x values, so just selected values. Gives us some f of x function, it gives us the derivative, some g of x function, and gives us the derivative of g of x. So let's go ahead and read the context of the problem. Again, anything we read throughout here, since this problem is A, B, C, and D, if we need any of this information below, it'll apply to all parts. The functions f and g are differentiable. That's important. For all real numbers, and g is strictly increasing. The table above gives the values of the functions and their first derivatives at selected values of x. The function h is given by the equation h of x equals f of g of x minus 6. So I underlined a few things that we need to talk about before we actually start the problem. So it's important that it says f and g are differentiable. If they're both differentiable, what else do we know about them? They're continuous. Remember, differentiability implies continuity. Continuity does not imply differentiability. So it's continuous. Okay. It says g is strictly increasing. So if g is always increasing, what do we know about the derivative? It's always positive. So those are some important things to know before we get started. Let's look at part A. Find the equation of the tangent line drawn to the graph of h when x equals 3. Well, we know our h function is this function given here. And they give us some x value. They want to know when x is equal to 3. So what do we need to find the equation of a tangent line?
We need to find the equation of a tangent line. We need to know the derivative of the equation.
Okay, eventually, yes. What two things do we need to know, though?
A point and a slope.
Yeah, that's what I'm looking for. We need a point and a slope. So Daniel said we need the derivative, so let's go ahead and start with that. We know the original is f of g of x minus 6. Do you have the derivative, Daniel?
Yes, you can use the composite rule to get f prime parentheses g of x, and you'd have g prime of x multiplied by that on the outside. Yeah, just like that.
Okay. So again, this function's inside another one, so kind of like the chain rule. So we take the derivative of the outside, f prime of g of x, keep the inside, and then take the derivative of what's on the inside, g prime of x. And then derivative of negative 6, it goes away. So this is the derivative. Again, that's composite, like Daniel said. It's inside another function, so do the chain rule. Okay. Now we need to find the point and the slope. And we're trying to find it. They give us at x equals 3. So we have the derivative. Let's go ahead and try to find the slope. Slope, h prime of 3. So that'd be f prime of g of 3, g prime of 3. That's just plugging in for the x. So now we have to actually use the table. We don't actually know what the function is, but we have the table up above with the selected values. So g of 3. What is the value of g of 3 using the table? Find 3 and go to g of 3. What is it? Sorry? 4. So I have f prime of 4 now. And that's multiplied by g prime of 3. Well, what is g prime of 3? 2. Okay. Do I need to find f prime of 4 first, or can I multiply the 2 and 4 first? Which do I need to do first? F prime of 4 first, yes. So using the table, find f prime of 4. F prime of 4. 3. So I get 3 times 2, so 6. 6 is the slope. Now we need the point. So I plug 3 now into what to find the point? The original. So h of x, or h of 3. f of g of 3 minus 6. That's the original. So I need to find g of 3. G of 3 is 4. So I have f of 4 minus 6. Well, now I need to go find f of 4. F of 4 is negative 1. Negative 1 minus 6. And I get negative 7. So now I have my point. Have my slope and I have my point. Now I just have to create the line. So my line would be what? Y plus 7 equals 6 times x minus 3. This is what they're looking for. Very good. Any questions at all about part A? I think we've done very similar problems. I think you should be okay how we arrived at that. Just make sure that you take the derivative correctly with that composition of the function there. Alright, part B. Find the rate of change of h for the interval 1 to 3. Find the rate of change of h for the interval 1 to 3. So what do you think they mean, or what do we need to get at here? What do we need to try to do? We want the rate of change over some interval. It'd be the same as finding what? Think about some of those theorems that we've used. Remember, you have a page with 4 theorems that might help you understand what they're trying to get at. If we're trying to find the rate of change over an interval. They're not asking specifically what the theorem is, but a theorem could help you understand what we need to do in this problem. Okay, so you could use that to help you. What operation, what mathematically do we need to do? Yeah, they give you an interval, a and b here, so you need to do your f of b minus f of a over b minus a, exactly. So we need to find h of 1 first. We need to find that value, and we need to find h of 3. Well, h of 1 would be f of g of 1 minus 6. H of 3 would be f of g of 3 minus 6. Didn't we already find h of 3? Yeah, that one we already found, so we know that's negative 7. We need to find h of 1. So again, you need to use the table from up above. Find g of 1. G of 1 is 2, so you get f of 2 minus 6. F of 2 is 9. 9 minus 6 is 3. Now again, that's your h of, or your f of b and your f of a, or your h of b and h of a, however you want to word it. So now you have to subtract them. Negative 7 minus 3 over your b minus a. So we found the rate of change over the interval. Again, that's just applying some of the theorems that we already knew. We know it was continuous and differentiable from up above, and they gave us this interval 1 to 3, so we could find the rate of change on that interval. Think we're pretty good so far? Alright, let's go on to C. So now we might need to think about those theorems a little bit more. Explain why there must be a value r for the interval 1 to 3 such that h of r would be equal to negative 2. Think about your theorems, read that again. Think about what they're asking for. Go through your 4 theorems that we had on that one page. Which one do you think is going to help you, and what is it telling us? Let's give everybody a moment to look, and then we'll go for an answer. All right, Daniel, do you still have an explanation there you'd like to
Yes.
fill us in on?
According to the intermediate value theorem, which states that as long as h of x is continuous on the interval 1, comma 3, there must be a value that of h of a that is greater than or less than y that is greater than or less than, but it has to be the same as the first,
Mm-hmm.
than h of b. So for example, the -7 is less than -2, and -2 is less than 3. And because that value is in between and h of x is continuous, there has to be an h of r that equals -2.
Exactly. So we're going to explain that in a little different wording, but you hit all of the points. You are correct. So first off, if starting this problem, we know we're talking about the intermediate value theorem. So we know we're trying to figure out some value between two other values. So they're talking specifically about 1 and 3. So if we think about h of 1, we found that that was 3. And if we think of h of 3, that was -7. So in terms of your endpoints, we're thinking about those two y values that we already found. And he mentioned it was continuous. So since h of x is continuous on the closed interval 1 to 3, and h of 3, so I'll write this two different ways. H of 3 is less than -2 is less than h of 1. Underneath that I'm going to write h of 3, which was -7, so that's the same as saying -7 is less than -2 and 3 is greater than -2. Those are the values for those. You don't have to write both, but just visually that's what we're saying. So since we're saying -7 is less than -2 and 3 is greater than -2, there must be a value r guaranteed by the IVT, intermediate value theorem, such that h of r equals -2 on 1, 3. So we're not saying at this point we know what this value r is. We're just saying there's some r between 1 and 3 that the y value, the answer, has to be -2. Because we know an answer before it has -7 and an answer after it has 3, and it's continuous. So that line somewhere has to touch -2. That's what the intermediate value theorem is saying. It's guaranteed by this theorem that h of r equals -2 somewhere on 1 to 3. Now we've covered that a few times in the past few days. Are we okay with that explanation? Alright, let's go to letter D. Explain why there is a value of c for the interval 1 to 3 such that h prime of c, the derivative, would be equal to -5. So how can we explain that? Look at your theorems, think about your theorems. Daniel?
According to the mean value theorem, since hx is continuous on bracket a comma b bracket and differential on parenthesis a comma b parenthesis, there must be a h, is it h of c or h prime c?
H prime of c.
H prime of c that equals hb minus ha over b minus a. And since we already did that, for the rate of change on the same interval, we can then just state that f prime of c equals -5.
Okay, very good. So we're going to say, since h of x is continuous on 1 to 3, sorry, closed interval 1 to 3, and differentiable on open interval 1 to 3, by the mean value theorem, there must be a value C such that h prime of C equals, and again we're using the interval 1 to 3, so it has to be h of 3 minus h of 1 over 3 minus 1 on the interval 1 to 3. So in the actual question they said they want to know if that h prime of C is equal to -5. So we could go through this work again, but we've already done the work up above. Again, the same interval as Daniel mentioned. So if you weren't sure that it was the same interval, you could do the work again. But it is the same interval. So when we calculate this, what does this equal? When you calculate this part over here, what does this equal? -5. Is that what we want h of C to equal? Yeah. It would equal -5. So h prime of C equals -5. And again, the explanation is because of the mean value theorem we explained, continuous, differentiable, so there had to be some value there. Again, this whole section, since we wrote down those 4 theorems, was how we're applying the theorems to problems. So being able to remember those theorems, you should try to start remembering those definitions so you can use them, because you're going to be able to apply those 4 theorems to different problems and be able to figure out the problems using the theorems. Any questions about this example as a whole today? Any part of it? Alright, since the 2-hour delay really earlier in the week messed us up with the schedule of things, you have quite a bit of time left, but the rest of today is going to be homework time. I'd like you to get a head start or study for the quiz tomorrow. So I'll get your partners ready. I'll let you know who those are. But quiz will be tomorrow, so you have homework time or study time the rest of today.